Hello, everyone, and welcome to another episode of Generative Geek. Today, we are going to focus on LangChain Expression Language. LangChain Expression Language allows for fast development of chains, and it makes use of the pipe operator the same way that you would have seen in Unix commands, where you have like one command, the output of one previous command becoming the input of the next command. Same way here, the output of the chain of the LangChain chain becomes the input of the next LangChain chain. This is, we touched upon it briefly. We discussed during one of our previous video. In this video, I'm going to touch more around the LangChain expression language and specifically around things like runnable pass-through, runnable parallel, and runnable lambda. The way we are going to do it is that we'll implement a small code today. What we'll do is we'll take some input. This code is going to take some input. We'll run runnable parallel, and that question, so the input is basically a question, right? And we would have ingested some knowledge through already in our ChromaDB, right? So we'll ingest some knowledge in our ChromaDB initially, and then create a retriever which will take this question to find the context, right? So that becomes the context, and our question goes as a runnable pass through. Runnable pass through, like I discussed in a previous video, just helps you pass whatever comes as an input, right? From the previous chains or previous layers or previous whatever is the user input. If there is nothing, no chain before that, you just take that. So in this case, the input is the runnable pass through, that is the question, right? And the runnable parallel is doing two things, right? It's saying, hey, you know what, get me a retriever and pass this question, right, to the next chain. So the next chain then takes it up and says, hey, now I have the context and I have the question. I'll add it to the prompt. We'll send that thing to the model. And whatever the model replies back with, we'll use that as an output and we'll parse that output to get the final output, right? So this is the code along that we'll do. As part of the code along, my goal is to help you learn more about runnable pass through, runnable parallel, and runnable lambda. Very important things, concepts. If you get them, you get how to create beautiful chains. And if you know how to create right chains, it becomes very, very easy then to create complex chains, build retrievers, pick knowledge, send it to a prompt, and get some very good output out, right? So let's get started. So I am on my Google Colab, and if you don't already have your keys set up in Google Colab, my recommendation is that you should set up your keys in Google Colab. The way to do that is just go to the secrets manager. I have various keys available here: LangChain, LangChain project, LangChain tracing, OpenAI API key, and I'm making all those keys available to this notebook. The way to make them available is just select this slider, and these keys will now become available in this. And as far as the runtime is concerned, I'm using a simple runtime, which is a CPU runtime. We're not doing any GPU stuff, so I'm on a simple runtime here. So let's get started. Right, first things first, we'll install all the necessary dependencies. I'm going to get started with installing LangChain. So pip install LangChain, pip install LangChain underscore OpenAI, pip install LangChain underscore community, pip install ChromaDB. We're going to use ChromaDB for the retriever. So it's going to be useful to have ChromaDB installed as well. Otherwise, at some point later, when we have to make use of it, we can again reinstall it. So while all these packages are getting installed, I think some of them are already installed. Let's get started with first things first. What I'll do is I'll bring my all my keys which are there in Google Colab in the secrets manager. I'm going to bring them here, right? I'm going to make them available in the environment. The way to do that is any key that you save here, you can call google.colab import user data, and within user data, the keys are user data is basically a dictionary of these keys. So you can bring these keys here in this environment, and this is how you get these keys: user data.get OpenAI API key. And then I'm setting them in the environment. So I've not imported OS. I'm setting them in the environment so that later modules which require these keys, they can look in the environment and find the key, right? So that's what I'm doing here. So this is the first thing. Once this is done, I'll get started with importing some of our LangChain API libraries, right? So from LangChain underscore OpenAI, import chat OpenAI, right? So this is the first one that I want to do. Next, we need some prompts. So I'm going to take langchain.prompts, import prompt chat prompt template from langchain.chains, import LLMchain, and we'll need some output parsers. So I'm going to make use of the str output parser here. From langchain.schema.output underscore parser, import str output parser, right? So we'll run this first. What I'm going to do is I'm going to run a simple LLM chain. If you go to langchain documentation and you say LLM chain langchain, and if you look at it, this way is now deprecated. It's available, but it's deprecated. I'm going to basically show you how you can create a chain using the LangChain way. This is the suggested way now, and we are going to make use of it. This is the LCEL way, the LangChain Expression Language way, where you can use the pipe operator. But let's say if we were running a regular chain, we would have done it through an LLM chain. This method is now deprecated, but it's available, right? We can still create LangChain chains using LLM chain. So let's first create a LangChain chain using the LLM chain. I'm going to first set up my LLM. I'm going to say I'll use chat OpenAI, and my temperature has to be 0. This means the model should not be doing a lot of hallucination. Because we had set up these things and made them available in the OS environment, I did not have to specify a key here. Otherwise, I had to specify a key. I would have been required to specify a key when instantiating this LLM. Next, what we'll do is we'll set up a basic chain using LLM chain. Create a basic chain using LLM chain, right? So the way to do it is, like I discussed in one of our previous videos, that when you look at a chain for us right now, a basic chain is nothing but a prompt, a model, and an output parser. So you take a prompt, you pass that prompt to the LLM, and that prompt goes to the LLM, and then is parsed by the output is parsed using the string output parser. So we are going to create a chain which will have the prompt, it will have a model, and it will have a string output parser. So let's say our prompt is, uh, we'll create a prompt. We'll say chat prompt template dot from underscore template, and we're going to create a template here which will be like, give me a report about some topic, right? So this is my prompt, right? And it's a very simple prompt. Also, we are saying output underscore parser is equal to str output parser, right? And our chain then should be LLM chain. LLM is LLM. We should first say what is the prompt. We'll then use the prompt. The way to describe it is, because these are like, named arguments. We don't have to follow what comes where. But let's say if a chain is prompt goes to the model gives some output which goes to the output parser. If you want to follow this sequence, then we'll say prompt is equal to prompt, LLM is equal to LLM, and output parser is output parser, right? So this becomes our chain in that case, right? So just for more readability, I'll bring them to new lines, and you can see prompt would have gone to LLM would have given some output, and given that output would have gone to output parser. Next, what we do is we'll say result, and we'll run this chain, and we can say, okay, maybe machine learning, right? So if machine learning is our topic and we want a small report about it, we can just run this thing. When we run this thing, what it is going to do is it is going to make a call. It is first going to craft this prompt. then send a call to OpenAI, because I'm using chat OpenAI using the key that is specified here. And next, it will parse the output using a string output parser that we are using. I can see what is the result. If I just type result, I can see what is the result that is returned. This is the result that came out. It says machine learning is a rapidly growing field, and it sent some interesting stuff out, right? So if I just say print, let's see if it prints it in a more beautiful way. Yeah, more readable way. Yes, machine learning is a rapidly growing field and all of that, right? So it gave me some stuff. So this is an example of a chain. Now let's just say if we were using the more appropriate way, which is the way that is described here, which is LangChain runnable way, or basically the LCEL way, which is the LangChain expression language way, where we use a pipe operator. We would have done things slightly differently. We would have said, we have defined everything already. So my prompt is already defined, my output parser is already defined. We would have said the only thing that changes is how we define the chain. So we would have said LCEL implementation. We would have said LCEL chain is equal to uh, prompt will go to LLM, and LLM will output will go to output parser, right? Very, very simple way. You don't have to now call a method and all of that. Internally, that is exactly what is happening, and when we talk about runnable lambda, you will understand what is actually happening. But for now, just assume that there is a prompt is getting piped to the LLM's output is getting piped to the output parser. Now again, same thing. We'll give it the same thing. We'll say, hey, result is equal to LCEL underscore chain dot invoke. Here you use the method invoke. If you look here, it says invoke. I think even run works, but run is now deprecated. So invoke, and we'll pass it some dictionary. We'll say, uh, given the fact that we need to pass a dictionary here, because that is what the model is expecting. In the sense, the model is expecting some it's expecting topic, and because the model is expecting topic here, we have to pass in a dictionary. This dictionary becomes whatever is the key here, will get the value of that key will get fixed here, right? That becomes the variable value here, right? So let's just run this, and see what the result is. And by the way, because I have already set up my LangChain tracing. If I now go to langchain.com and I log into my LangChain console, I should be able to see on Langsmith all my, if you look at my project, let me just see what is the project name. It is Generative Geek. My project is Generative Geek. So within the Generative Geek project, I should be able to see my all my uh, traces there, right? So let me just show you quickly. I have 5 projects running, and Generative Geek is the one where all these calls should be getting stored. And if you look at these 2 calls, machine learning, which is for today, 10th of May 2024 at 7:53 at my place right now. You see that these are all renewable sequences, right? So chat prompt template, then chat OpenAI, and the strict output parcel. So this is the chain that we were running. This is the sequence in which it was running. And Langsmith tracing is a very interesting way. All you have to do is, I already have a video on it. Just browse through the library. I don't have a lot of videos at this point of time. You should be able to find them. So just go there. All you have to do is set up your some keys, and you are through, right? So now we got the result back. We got a longish reply, it feels, but nothing has changed. Like now, the model is still doing. The prompt is still the same. The LLM is still the same. The output parser is still the same. It's just the entropy at play, right? So there's nothing that has changed as such. Now what we'll do is, we I just quickly showed you that how you have like a generic or a traditional way of defining chains, which was through an LLM chain, which is now uh, uh, which is now deprecated, and you have a more LCEL way, or the more recommended way now, which is you use pipe operators and the LangChain expression language, right? So now with this, we will get into the place where we'll make use of some runnables, right? Um, so whenever you see, like, these pipe operators, think of them like, as if they are calling the or method on the first object and passing the second object to it, right? So that's one way of intuitively thinking about it, that hey, in this LLM, probably there is some method inside, and in that method this entire thing is getting passed, right? So that's one intuitive way of understanding. Now let's get to the chroma part of it, but let's set up chroma first. So I'll write from langchain underscore community dot vector stores import chroma, right? So we'll use ChromaDB here for our retriever and ingestion of some information that we want. Chat OpenAI is already done. We'll need OpenAI embeddings, right? And if you remember from our Chroma video or from any vector database video that we did earlier, uh, in order to create a vector collection, right, where you will basically, collection is like a table. All you need two things for sure. One is the name, and another is what kind of embeddings are these, right? So how will this text that you are sending, or the information that you are sending, going to get converted into the vector space? So you have to define these two things: what is the name of the collection, and how are this text going to get stored in the vector space? How should that conversion happen? That is called the embedding function. So we are going to use OpenAI embeddings here. Next, let's quickly define our vector store. So we'll say define get vector store, and we'll say embedding underscore function is equal to OpenAI embeddings. Unless you want to do something else, Hugging Face has a lot of, if you go to huggingface.com.co and you just search for models, and you go to a lot of embedding models, you should be able to find a lot of embedding models here, right? So if I just do filtration on embedding, there are so many various embeddings I can use, and most of them are free and open source. I have a video on how you can use some of these open source Hugging Face models right now, using just the Hugging Face key. I'm not getting into it right now in this video. So we are using OpenAI embeddings. For that, you need a OpenAI key, right? But if you want, you can use a Hugging Face model as well. We are going to define the storage directory. I'm going to store it in a folder called embeddings. Then what we'll do is we'll also define a collection name. And I'll tell you why I'm doing this. Why do we need to define a collection name? With this, these are the three things that we'll define. I want to say vector db is equal to chroma, persist underscore directory is equal to storage underscore directory. We are going to say embedding underscore function is my embedding function, collection name is collection name, right? And this will basically create a vector db, which I'm going to then return, right? So we'll run this. I have just defined the method get vector store is a method which will now allow us to create vector stores, right? Using ChromaDB. So I'm using Chroma here, right? And because we installed Chroma earlier, I think we did pip install ChromaDB. So because I installed ChromaDB and I'm asking it to create embeddings here, so far nothing has got created, but once it gets created, you will be able to see in your file folder here that some embeddings will start showing up, right? So some new folder will get created. So now what we'll do is we'll say I'll create, this is the part where we are right now, right? So we are setting this retriever part first, but in order to set up the retriever first, I need to add some information to my chroma, right? So to my ChromaDB collection, I'm at that point right now where I'm adding information, right? So vector store underscore a is equal to get vector store. I'm calling it vector store A. This is the first vector store that I'm defining, and I'll tell you why. Because I want to basically do this in two ways. Where, sorry, I want to set up 2 vector stores, because this retriever, I want to show how you can use runnable parallel. right? So instead of having just one retriever, I'll have two retrievers. Two different tables will get scanned, right? Think of it. You send a question, a parallel stream opens, and that thing is making a call to two different tables in one go, getting inputs from those two tables, and then forming the context and sending that question along with the context to the prompt. That's my goal here, right? So this retriever here is not one retriever. Think of them as two different retrievers. We'll define vector store A, and then we'll define vector store B, right? And you will understand what I mean, right? So collection name is vector store underscore A. If I just run this, basically my first vector store will get created. Okay, could not import, please install with pip install ChromaDB. I thought we already did. Maybe something went wrong. Let's just again run this. Requirement already satisfied, requirement already satisfied. Sometimes what happens is when you're using Chroma or when you're using Colab, the runtime can get disconnected, and because of that, there are times when it might not find the installed libraries, right? So, but though right now we are seeing that everything is showing up as satisfied. Let's just see, right? So now it is installing something. Maybe ChromaDB was not installed last time we ran, for whatever reason, right? So, um, yeah. So once ChromaDB gets installed, I'll again import these things, and then we should be able to run. So you got it, like why we got that error, because at this point when we defined the method, there was no call going to Chroma as such saying, hey, you know what, create a DB. These are all lazy loadings in a way. Hey, here, this I have just defined it. Nothing has actually gone inside Chroma's code and said, hey, create something for me. That happens when I actually ask it to run this thing, right? So till then the method is there, but that method has not been checked whether the contents of the method are actually true or not, right? Whether they can run or not. Now let's run this, and now our collection got created, right? What I'll do now, I'll just quickly add some stuff here. So I'll say vector store underscore A dot add underscore text, and here I can define a list which I want this vector store A to hold. So I'm saying half of my text will be part of A, and I'm saying VP's birthday is on 1st October. Yeah. So I'm just defining these two things. I'm adding this as part of the vector store A, and it gave me the IDs that it has generated for these two. You don't have to do anything with them, but just for the sake of knowing, you should know that these are the IDs, right? So now I'm saying vector store underscore B. We are going to create another vector store, and we are saying get vector store collection name. This time will be vector store B. And once we do this, we'll also add text to this. We'll say vector store.b add underscore text, and then same way, half of the text is part of B. And so you can see I'm basically saying I'm giving one, I added one part of the information here, and I'm adding the second part of the information in another table, right? So VP's birthday, or VP was born on in 1981, right? So let's just say if I add this, these are two. Okay, chroma j and underscore, it should be add text. So what I've done is, instead of saying hey, VP was born on 1st October 1981, I'm saying there is one table which has information which says VP's birthday is on 1st of October, and there's another table called vector store B which has information about the year, right? So there are like two different informations which are part of this. So instead of this being one retriever, these are two retrievers, right? So maybe think of a more natural, more appropriate production way, where your customer information is part of one table, but your order history is part of another table, right? So think of it this way, right? So we have two tables here, right? So now, and we have added this information. so in our vector stores. So now our vector stores are done. If you just want to see, you can see vector store underscore a dot collection dot underscore collection, and you will see the name of the collection is vector store a. And if I say vector store underscore b dot, what I'm trying to show is that, hey, these are two different collections within Chroma, right? So these are two different tables. And if you go to your folder here, and you can see there is embeddings which are showing up, and there are two different folders here, right? So, and within this there are several things which, because these are binary, this is binary, you won't be able to read it. But it's good to know that, hey, this is showing up there, right? So now if you want to just see, hey, what is the total items in vector store a, I can just do vector store underscore a dot get, and I can get all the IDs, and then we can do a len on it. It shows 2. And if I do a len on vector store underscore b dot get, and I do it on the IDs same way, I should say 2 comma 2, right? So both of them have two items. If I can add another item saying, hey, VP is a friend of BP, right? So let's just say, right, random stuff, right? Let me just define this again, because what happened is, the moment I did this, now if I do a collection count, you will see that, one will have 2, the other has 5, right? So new things got added, same information has got added twice now, right? It's all right, nothing, no worries at all. We'll just keep going, right? So now what we'll do is we'll import the two new classes, right? So we'll say langchain underscore from langchain underscore core dot runnables import two things that we want to import: runnable parallel and runnable pass through, right? So runnable pass through we made use of in our previous video, where we built that customer review bot, customer review processing bot. Now we are also going to make use of runnable parallel. So let's now define two retrievers. So retriever a is vector store a as retriever, vector store b as retriever, right? So, and if you want to understand what these things are, my suggestion is just go to just go to this one. Where are we importing Chroma? Yeah, so go to this, just google this, go to this vector stores, read through this, right? You will see, if you look at retriever as retriever, right, returns vector store initialized from the vector store, right? If you go inside, you can see, hey, what are the optional parameters, how can I change this, what is fetch k, how can I change that? I strongly suggest, like, you go through some of these things, you will learn a lot just by going through the documentation of these things, right? If you know, and let's just say, if you don't know anything, right, you find this code very hard to read, give it to ChatGPT, saying, hey, you know what, if you have a paid subscription, great, because GPT-4 is really good with reasoning. If you don't have, give it a very good prompt saying, hey, you know what, this is a retriever, retrievers are these, what do you make out of this code? And you will learn a lot, right? In just by giving it, I sometimes just do a control a, control v, control c, post everything to chat gpt, and then I start asking it questions. This way I have learned a lot, right, in my own journey. Yeah, coming back to our code now. So we have two retrievers set up here. Now I'll create my prompt. So we have, let's assume we have this part set up now, right? So the retriever part is set up. We have two vector stores and we have two retrievers set up. First, what we'll do is I'll create a prompt string, and we'll call it, we'll set up the prompt string as answer the following question basis the context that is provided. Okay, and we'll say context is context and question is question, right? So I can even add a new line here. Yeah, so this becomes my prompt, and we can say answer is what we are expecting, right? So this becomes my prompt string. Using the prompt string, we now define a prompt. So this becomes, we'll use chat prompt template. from prompt, from template, and we'll give it the prompt string. Now our prompt is ready, right? So our prompt is ready. This is ready, right? Um, what we now need is, and we are first, what we are doing is we are building these things, right? We're building it, all of them in separations, and then we'll start plugging them together, right? So our retriever is ready, our prompt is ready, output parser, we don't have to do anything, model, we don't have to do anything, question is already there, right? Question can be sent as part of the chain. So now what we'll do, once these things are ready, we'll create our runnable parallel. So let me just create this part, right? How the input will come and go to the retriever. That part I want to now start. So I'll say my retrieval, I'm defining a retrieval, and I'm calling it runnable parallel. And within the runnable parallel, we'll say our context is retriever underscore a, and our question is runnable pass through. I hope this makes sense. What we are doing is very simple. We are saying, hey, create a runnable parallel, create a parallel process, but right now the context is only retrieval A. We are not giving the B part to it. So this, when the prompt actually hits when the prompt gets created and it hits the model, it will not know anything about this B part. This will be unknown. So it won't know that, hey, 1981 is also something, right, to do with VP. It will know that VP's birthday is on 1st October. It won't know that VP and VP are friends, and 1981 is when VP was born, right? It will. So this is by design. I'm giving it only very very little information, like very specific information or incomplete information. Next, we'll define the chain. We'll first say my chain is retrieval. We'll create the retrieval part first. I'm asking it that, hey, first get this part in. Then once you have the retrieval, go create, send information to the prompt. Why are we doing it this way? Because retrieval, if you look in this, is before the prompt, right? So retrieval has to be done before it is sent to the prompt. Once the prompt is done, you have to send it to, I think something is wrong or what. No. Okay. So retrieval prompt LLM, and when we get the output, we'll send it out to the output parser, right? So with this, our chain will be ready, right? So this chain is now ready, this entire thing is now ready. All we have to do is give it an input, and everything will be done. So now this entire thing, right? So this entire thing, from this dotted line till this, is ready, right? So our runnable parallel is ready. We are saying, hey, the context in the prompt has to come from retriever A, and the way the retrievers work is that they will also take a question, right? So when you run this retrieval A, it will take a question, right? So it will take a question, and this question will become the basis for which the vector store A will answer, right? Whatever it will return will be part of the context, and this question has to go as a pass through, right? And that's the reason we have here the question coming from this side, right? So the chain will run, and now we'll say chain dot invoke. Oops, I did not send any question. I pressed, so therefore it is saying I need an input, right? So when was VP born? That's my question, right? So let's see. Input to chat prompt template is missing variables. I think some problem with the okay, so here we have a spelling error. It should be question. So see, for us, if you look at the error, it says question J, right? So what is happening is, when you are sending this as an input, it is expecting this key, right? It was expecting this key. It did not get this key, and therefore it complained. It said, hey, I did not find question J, right? Whatever it was, however you spell it, right? So yeah, let's run this cell again, let's run this again, let's run this again. Now let's see. And if you go here to generative geek, see, I'm getting a sequence here. The sequence is, there is a retriever. The retriever is, query is, when was VP born, and I have two documents which says VP's birthday is on 1st October, and half of my text will be part of A, right? So now this becomes part of the context. Chat OpenAI is now sending this saying, hey, answer the following question basis the context. Context is, this is a document that VP's birthday is on 1st October, and this is the second document, right? So half of my text will be, and when was VP born is the question. VP was born on 1st October. So it is not able to give me the year, right? So because it doesn't have that information, if you look at it, right? Now what we'll do is we'll enhance the prompt string, right? So we'll enhance the number of requested results 4 is greater than the number of elements in index 2, updating n results to 2. Okay, so that's just a warning. We are now saying prompt string. We had this prompt string. I'm just going to copy this, and I'm going to enhance the question, right? This time I'm going to say context is no more just context. There is context underscore a, which will come from retriever a, and I'll also add a new context to it, and I'll call it context b, right? So I'll say context b, right? So this will become my context b. So this becomes, I now have a more enriched string, and now my prompt will expect two inputs from me, right? So let's see how we'll do it, right? So last time the way we did it, we first created our prompt string, then we created the prompt. Same thing is now ready. I'll run this. After that we created a retrieval, right? And we'll do the same thing. We'll say, hey, retrieval this time, uh, retrieval enhanced is equal to runnable parallel. And this time what we are going to do, we are going to pass it a context a. We are required to pass it a context a. We are going to say context a is retriever a. Next we are passing it context underscore b, and this is basically retriever b. Okay, next it is also expecting a question. See, when you are creating a prompt template, it is expecting all of these things to come in as part of an input from somewhere, from either from a previous layer or from an input. It doesn't know, it just needs that from somewhere, right? So the question for us is a runnable pass through. When we say runnable pass through, we are just passing it, whatever we got we are passing it, right? So this becomes my runnable pass through. So my retrieval enhanced is also now ready. With that I can say my chain is retrieval enhanced prompt LLM output parser, right? So this time we are using two different retrievers, just so that the information is more complete. Again, now with that I'm going to run the same thing, same question. When was VP born? When was VP born? Let's see what answer comes back, right? Number of record, VP was born in 1981. Now again this time what has happened is, and let's go to Langsmith, right? So if I look at this and I see the retriever, it is saying VP's birthday. This is retriever A. It says VP's birthday is 1st October. This is retriever B. VP was born in 1981, 1881, half of the text. So, right. And Chat OpenAI, let's see what Chat OpenAI got. Chat OpenAI got four things, right? So it got everything, right? Actually, it got that VP's birthday is on 1st October, and it also got that VP was born in 1981. Ideally, it should have replied back saying, hey, VP was born on, maybe my prompt needs slight enhancement, right? So I should say, when was VP born? Instead of this, maybe let's just ask it, when was, give me the day, give me the complete birth date of VP, right? So let's see what I get back. VP's complete birth date is 1st October 1981. But let's say if I was doing the same thing with my previous one, right? You know, when I had run it here, if I, not here, maybe let's just add another code line, and we'll define this thing again. Chain.invoke. When was VP born? VP was born on 1st October. Give me the complete birth date. Let's see. VP's complete birth date is 1st October. It doesn't have the information, so it cannot give me the year, right? So what we did, guys, we basically have done this entire thing. We created a runnable parallel. We brought in two retrievers this time, two different collections. We created a runnable pass through, and our entire chain, entire thing of this RAG demonstration is done, right? This, we created this. We are done with runnable pass through and runnable parallel. Now, let me very quickly show you and make you understand what a runnable lambda is. So, runnable lambda, think of them more like LangChain abstractions that allow us to turn Python functions into pipe compatible functions, right? So let's say you have some Python function. Let's say, let me first show you from langchain underscore core dot runnables, import runnable lambda. And let's say I have two functions, right? So I have let me just code copy paste. So I have, let's say, add 5 and multiply by 2. Let's say if I have these two functions and I want to make them pipe compatible. Right now, I cannot use them here in the pipe, right? So the way to do it is, I'll first create a lambda using runnable lambda. I'll pass this function here. So I'll say runnable lambda multiplied by 2. Runnable lambda add 5. So I have two lambdas now, right? And when I have these two lambdas, I can create a chain. And my chain will say, first I want the add 5 lambda, and then I want to call multiply by 2 lambda, right? So this becomes my chain, that hey, whatever is the output of add 5 lambda, because add 5 lambda is returning something, so whatever is the output, I want that output to be the input of this, and this is accepting some input. So this x is basically nothing but this output, right? So how do you now go out and give it the input? Same way that we did earlier, chain dot invoke, and we'll ask it that, hey, you know what, chain dot invoke 10, right? So I got 30 back if you look at it. So the what happened is, first we called add 5 lambda. So 10 plus 5 is 15. 15 became the input of multiply by 2 lambda, and 15 into 2 is 30, and that therefore the answer is 30. If we had swapped it saying, hey, this has to come after multiply by 2 lambda, the chain is very different. So now let's just add 5 lambda. Now the chain is very different, and we'll invoke the chain with 10. We'll get a very different output this time. So add multiply by 2 lambda will make 10 20. 20 plus 5 is 25, and therefore you got the output as 25. So that's it, guys. I hope this made sense to you. I can show you a little more useful example, in the sense, let's say you have some sort of a branding info that you want to add to your emails, right? So let's say add branding info, and this is my branding info, which is generative geek demo, report follows, and whatever is x will get printed after this. I can convert this also into a lambda, right? And now what I'll do is, I'll say my LCEL chain is prompt LLM. And but what is the prompt? So the prompt is, let me just quickly, I have this code ready. My prompt is chat prompt template, give me a report about topic. Same thing, my LCEL chain becomes prompt LLM output parser. This becomes my result. Result is LCEL chain for topic is market mix modeling, and will print the result. And I want to add branding info. I want to make that a runnable lambda, right? We'll not do all of this right now. We'll do it here. So once I invoke LCEL chain, I should be able to see now, right? I hope it is making sense. I don't even need this. I only needed the prompt. So my chat prompt template is give me a report about a topic. Add branding info is the runnable lambda. When we are doing this, the topic becomes learning about LangChain, right? So uh, let's see what happens. Expected mapping type as this, received class str. Okay, let me just quickly see what is going wrong. Okay, so the error is fixed. I had to rewrite the code. Here is what we have done. We have added a new method called add branding info, and we've created a lambda out of it. Next, our chat prompt template says give me a small report about a certain topic. My LCEL chain is prompt LLM output parser, and this is something that we discussed earlier at initially at the start of this lecture. We print the result, but now what I have done is I have enhanced my LCEL chain from prompt LLM output parser. I have also added branding info, because this market mix modeling, this report, let's say if this was a report, it doesn't have my generative geek branding. So I'll use that as part of the chain, but this time my topic will become learning about LangChain, and I'll just press this, enter. Now it will make another call. Finally, once the output parser returns the output, string output, it will now call add branding info, and you can see generative geek demo report follows, and this is the same report that the output parser would have returned. So this is it, guys. I hope you learned something new. This is about runnable pass through. Today, our goal was to cover runnable pass through, runnable parallel, and runnable lambda. I hope I was clear enough and helped you understand how these things work. If you enjoyed this lecture, do like, subscribe, comment. It will be very useful and very helpful for me. And definitely do share your feedback. Thank you so much.